Okay, welcome to Unit 6, Lesson 4. We're talking about fitting a line to data, and your two objectives are there. Go ahead and get them written down. Let's get started. Okay, when we talk about fitting a line to data, we're going to be talking about scatter plots. Okay, and a lot of times scatter plots are used to represent data because they're not always going to fall in a straight line. Okay, so if you look at the scatter plot that's up here, you got data points all over the place, and you can never connect them with a straight line. Okay, so a lot of times scatter plots are going to be used to represent data because that's the easiest way for us to represent it. And a scatter plot is just a graph of paired data in which data values are plotted as xy coordinates. And the dependent variable is the y-axis and the independent variable is the x-axis. Okay, so independent means that it can stand by itself. It doesn't change based on something else. So another word for these are inputs and outputs. Okay, our output changes based upon what we put in for our input. So the output depends on what the input is. Okay, so that's why they're called independent and dependent variables. But this is what a scatter plot looks like, and this is what we're going to deal with. Alright, let's move on to the next slide. When we talk about scatter plots, we have to talk about something called correlation. Correlation is the degree to which two variables are associated. Okay, so if you look at this scatter plot here, this is a scatter plot, or what a scatter plot would look like if it has approximately no correlation. Okay, and what that means is it's a relationship in paired data in which there's no pattern. Okay, so we can't necessarily say that as these numbers increase, that these ones increase. We can't necessarily say that as these increase, these ones decrease. Okay, because the points are just kind of all over the place. So there's really no correlation there. Alright, now on the next slide we're going to look at when there is correlation. So let's go ahead and do that. Okay, on the left we got positively associated data, and that's a relationship in which paired data in the two sets tend to increase together, and it follows a pattern from the lower left to the upper right. So it looks like it's going uphill from left to right, kind of like a positive slope. Okay, so as we go this way, it seems like the data points go farther and farther up. Okay, as this one increases, this one also increases. Alright, so that would be positively associated data. Negatively associated data are when one variable's values increase and the others decrease. Okay, so if we look at this one, our x's are increasing, and as our x's increase, our y's are going downhill. Okay, so as these increase, these y's get lower. That's negatively associated data. It looks like it's going downhill from left to right, just like a negative slope. Okay, and notice these lines we drew in here, those are just drawn in to show that it's going uphill or downhill. Okay, the actual points are here on the scatter plot. Alright, let's go ahead and keep on moving on. Okay, when we make a scatter plot, it's often helpful to come up with a line of best fit. Okay, and a line of best fit is a straight line drawn through as many points as possible with approximately the same number of points above the line as there are below the line. So if we look at this scatter plot here, okay, we can come up with a line of best fit. And again, we want our line of best fit to run through some points if we can. It doesn't have to, but the main thing we're looking at is where can we put the line so that we get about an even number of points above the line as below the line. So if you look here, we drew in this line. Okay, this line only crosses one point in the entire scatter plot. Okay, but if you look, okay, we got 1, 2, 3, 4, 5, 6, 7, 8, 9 points below the line, and then above the line we've got 1, 2, 3, 4, 5, 6, 7, 8 points. So 9 above, 8 below, and we hit 1 point out of the whole data. So this is our line of best fit. Okay, this is a line that best represents what the data is doing. So if we draw this line in here, okay, you can see that our data is trending downward the farther we go on the x-axis. So again, that's negative correlation, okay, because it looks like it's going downhill. Alright, so again, line of best fit is a line that we would draw in to have about the even number of data points above and below the line. Okay, let's go on to the next slide. Alright, so this is now going to be our last example just for the sake of time. I think after this one we should be able to get it down. Okay, so this says write an equation for the line of best fit. Alright, so here's our scatter plot of our data. We've got some age ranges here and your annual income. Okay, now this little squiggly line here just means that we're kind of skipping ahead from age 0 to age 35 because that's what they decided to represent this data with, so maybe that was all the people they interviewed for this, asking about their incomes and their ages. So step 1 says to draw the line of best fit. Okay, and here are your two key points for drawing a line of best fit. first thing you need to do is try to intersect as many points as possible. Okay? That doesn't necessarily mean I want to draw points that go like this. Okay, to intersect 3 points or whatever it is. Okay, because step 2 is also very important. It says to leave the same number of points above the line as below the line. So we want to try to have an equal number of points above or below the line. So if I connected these 2 points right here, then I'd only have 2 points above the line and a bunch of points below the line. If I connected these 2 here, again, I'd have way too many below the line. If I connected these 2 here, it's closer, but still not quite good enough. Okay, so what Mr. Ayers is going to do is he's going to just draw a line through this point here, and it's going to run right up kind of through the middle of this data. Okay, so when I do that, I should be able to get an equal number of points above the line and below the line, and one point that's actually on the line. Again, I don't have a straight edge, but you guys need to make sure that you use one on this, so we're just going to kind of guess on this here, and run this right up through there. Okay, now look at Mr. Ayers' line. Don't draw this yet, okay? Because look at my line. Now if I use this as my line of best fit, there's a problem. And if I look above my line, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 points above the line, only 5 below the line. So that's not a line of best fit. Okay? So I want to make sure that my line angles up a little more. So I'm going to go ahead and erase that line that I just drew. So again, it's not good enough. I still want to use this point, but I need to make sure that I angle it up a bit more so that it's not touching these ones. Okay, so we're going to go ahead again and try to draw one right through here without touching those 2 points. Now we've got a line that if I look, I've got 1, 2, 3, 4, 5, 6, 7, 8 points above, and 1, 2, 3, 4, 5, 6, 7 points below, and we had this one point that was right in here, okay, that we can't really see anymore. And we're going to have to use that point, so I'm going to go ahead and write it down before I forget what it is. Okay, it's about 37 and 48,000. Okay, when we look at that point. Okay, so 37 and 48,000 is about right here where that point was. So where 37 is our age and 48,000 is the income for that age group. Okay, so we got our best fit line, or our approximation anyway. Again, it's just kind of an eyeball test, meaning we're going to just use our eyes and try to figure it out. There's really no other method for it. Now step 2 says to pick 2 points from the line and line of best fit and write an equation. So we learned how to write the equation of a line when we're given 2 points. Alright, so that's what we're going to use here. So the very first thing I'm going to do is rewrite my first point that I already picked that was on the line, 37 and 48,000. Okay, where this is my X and my age, and that's my Y, my income. Then I need to pick another point. Well, the key here is to pick a point that's on the line, not one of these points off the line. We don't care about those anymore. I want a point on the line. So I want to find one that's approximate. Okay, so right here we got a point about on the line that's about at 45 and 75,000. So I'm going to go ahead and pick that one. So really, there's a lot of kind of guesswork involved here and some educated guessing. So your answers may be different than the book, and that's okay as long as they're pretty close. Okay, when you're grading these. Alright, so now we're going to use the method we learned before to how to write a line, or the equation of a line when we have 2 points. So again, think about how we write lines, okay, what format. We're going to have y equals mx plus b form. And again, to write an equation in that form, I need to know my m and I need to know my b. So we're going to start by finding the slope. So we're going to go, this is x1, y1, and x2, y2. And we're going to go ahead and find the slope of this line. Okay, now look at these numbers. It might get kind of messy. That's okay. Okay, we can handle big numbers. That's fine. So we're going to do y2, 75,000, minus y1 is 48,000, over x2 is 45, minus 37. Well, 75,000 minus 48,000 is 27,000, and 45 minus 37 is 8. Now reducing this, okay, 8 actually goes into 27,000, and it goes in there 3,375 times. So this equation reduces down to 3,375 over 1. So that's going to be my slope, my m. Okay, So m is equal to 3,375 over 1, or just 3,375. Okay? Now I'm going to erase this work just to save myself room on the screen. You need to keep it and follow along down below. Okay? So again, I'm going to erase this work that I've shown here. Maybe, if it'll let me. Okay, whoops, I'm going to need to rewrite that. My m was 3,375. Okay, so my m was 3,375. We just found that. Now I need to plug in to the y equals mx plus b form, again, to find my b. And Mr. Ayres likes using points that have smaller numbers, okay, because they're usually easier to work with. So instead of y, I'm going to put in 48,000 equals m, which was 3,375, times x, which was 37, and plus b. Well, 3,375 times 37 is 124,875. Okay? Then I'm going to subtract 124,875 from each side. And that's going to give me an answer of negative 76,875 for B. So my B is negative 76,875. Now you might be thinking, well, wait a second, Mr. Ayres. That's not possible. I can't make negative $75,875 a year. And that's very true, okay? But if we look at our line here, since we're looking at pretty much from age 35 to 60 on this, our line's got to intersect and go negative somewhere if we kept drawing it on. Okay, so that's okay for this line. It's not going to really mess up our line of best fit. Okay, plus at age 0, you wouldn't be making any money anyway, so the negative number doesn't really mean a whole lot. Alright, so let's go ahead and write our equation now. So we know we've got y equals mx plus b form. And now we just want to plug in our m and our b. So we're going to get y equals 3,375 times x plus, and my b is negative 76,875. And there's my equation for my line. Okay? Now let's say I wanted to test this and see if it works for my line. Okay, I can plug in numbers. Let's say I picked a 50-year-old. So if I take 3,375 times 50, I'm going to get 168,750. And then if I subtracted 76,875, that's going to give me an answer of 91,875. So that's telling me that a 50-year-old on my line should make about $91,875. And now if you look on this, again, my line's a little curved, okay, so it doesn't work out quite so well, but you can tell 50,000 is going to be up here somewhere in that range. Okay, so that's not too far off from where we want it to be. And more of that fact is just because there's a lot of guesswork here, okay? So your answers aren't going to be exact, but it's the idea, okay, of how to pick a line of best fit. So again, there's my equation for my line of best fit. Alright, if you got any questions, ask. Otherwise, good luck on your homework.